So with example 3, be sure to reference the graph that's directly above this video that's given with the problem. As it states, it says the following graph shows the distance traveled per hour on a biking trip on the Katy Trail. So the x-axis is time in hours, the y-axis is distance in miles. And essentially we want to just find the points that we know are on the graph. Preferably we want to use integer values just because that makes things easier. So if we look on the graph, you should notice that at 2 hours, so we're looking for coordinates, hours versus distance in miles. So at 2 hours, it appears that the distance traveled is 20 miles. At 4 hours, it appears that the distance traveled is 40 miles. And at 10 hours, it appears the distance traveled is 100 miles. And we could set this up also in a table. We would simply just have, our normal XY table. Instead, we'd have hours, distance traveled. So we'd have 2 and 20, 4 and 40, and 10 and 100. And these state the same exact thing. It's just a different way of looking at them, and you could write them out whichever way you prefer. So now what we're going to do is we're going to look at the change in distance over the change in time in hours. So we'll use the two extremes first. 100 minus 20 over 10 minus 2. That equals 80 over 8, which equals 10. And that would be miles per hour. We could use 40 minus 20 over 4 minus 2, so 40 minus 20 over 4 minus 2, that equals 20 over 2, which equals 10 miles per hour. We could use 100 minus 40 over 10 minus 4. Again, this is a change in distance, so we're going from 40 to 100 miles. Over the change in hours, so we're going from 4 to 10, so that equals 60 over 6, which again equals 10 miles per hour. So our constant rate of change for miles per hour on this trip is going to be 10 miles per hour.